Alright, in this video we're going to be going over some of our square properties and applying them in numerical examples. So this should say lesson 7 instead of lesson number 8. Now, the first thing we're going to do is go over our family tree situation. So make sure you're lifting up all the flaps that are in yellow or that are highlighted here so that you're writing on your family tree portion. So right now, we are kind of with a square. This is the very last shape that we're going to be learning in this unit. And what a square is it's the combination of a rectangle and a rhombus. So we're kind of coming together here at the end to create this square. Now let's go over the actual properties of a square. So make sure you're lifting up all of the highlighted portions of your flipbook. And this shape, again, is significant because it's a combination of a rectangle and a rhombus. So a square is a parallelogram that inherits all 5 of the unique properties of a rectangle and a rhombus. So a square is a parallelogram with congruent diagonals and all angles being 90 degrees. So if you recall, these were the 2 properties that formed or that helped us create our rectangle, right? Those were the 2 unique things. And though a square also needs to have perpendicular diagonals, the diagonals need to bisect the angles of the shape, and all sides need to be congruent. Now, if you remember, these were all of the properties of a rhombus. So a square is inheriting all 5 of those unique things, and it's being put into one shape. So it's not a rectangle or a rhombus, it's both of them put together. So it's interesting to know kind of where the sets of properties come from. But let's make sure we know how to label our image. So here we have a square ABCD. So we know that if we draw our diagonals in, we still know, right, that property of our diagonals bisecting each other is still true. That's true for every single parallelogram. However, more strongly, we know that our diagonals are congruent, which means that when they're bisected, we know all 4 of those portions, all 4 of those smaller pieces are going to be the same. Now we know that all of our corner angles, or all of our angles of our shape, are 90 degrees, so we can go ahead and label that in there. And that kind of goes along with these 2 properties here. Now, I'll redraw our square here to kind of label this next set of properties. We have A, B, C, and D. Now, when we redraw our diagonals in here, we know that they're perpendicular. Now, what that means is that at their intersection point, we're creating those right angles. And we know the diagonals bisect the angles of the shape. So that means that these diagonal lengths here are cutting angles A, B, C, and D up into even pieces. Now, we can make another observation here because we know that all 4 angles are guaranteed to be 90 degrees. So if all of these angles are being bisected, we can even more strongly label the fact that when we have our diagonals, each smaller piece of those angles are going to be 45 degrees. And this is always the case with the square, right? If all 4 of our angles are always 90 degrees, and we know that our diagonals are cutting those angles in half, all of those smaller pieces are going to be 45, which is very interesting. We're probably going to need to use this fact a lot throughout the task card and as we work on these shapes. And then last but not least, we know that all sides are congruent. So we can go ahead and label, use 2 tick marks here. So obviously, I drew 2 separate diagrams to kind of show you guys the different sets of properties, but these are for the same exact shape, right? So I can also label all pieces of the diagonal being congruent, and if we wanted to go ahead, we can put the boxes in for each angle. It just gets a little bit messier, so sometimes it's nice to see things separated a little bit. So let's just get into 2 examples. We're always going to just ask ourselves, what property are we using? So let's get right into it. It says, given square cane with diagonals intersecting at B, it says the measure of angles C and E is 3A plus 2B, AC is 35, and CE is 6A plus 5. Okay, so the first thing that I'm going to do, I know that it's a square. So since it's a square, I know that I can use any of the 5 properties, plus properties of a parallelogram if I needed to. But what's standing out to me is that they give us this value of 35. So I'm going to use the fact that all sides of a square are congruent, and I'm just going to go ahead and label the other sides as 35, because that might help me visually see what's happening here. Now, it wants us to find A and B. So with what I'm seeing right now is I have side CE labeled as 6A plus 5, but it also, I know that that's going to be equal to 35 as well. So I'm going to take CE, and I know that 35, which is that side length, has to be equal to 6A plus 5. So if we subtract 5 on both sides, we'll get 30 equals 6A, so we'll be able to find out that 5 is equal to our A value. Now, the next thing that we haven't addressed yet is that this angle CNE, which is right over here, so angle CNE is just this portion right here, is equal to 3A plus 2B. Now, with this property, or with this given, we're going to be using the property that not only are all angles 90 degrees, right? I can go ahead and I can put my boxes in there to show us that all of those angles are 90. But what we further know about a square is that our diagonals are bisecting those 90-degree angles. So in our square, when our when our diagonals are present, we know that all of these little angles, keep doing that, we know that all of these little angles are going to be 45, 45, 45, 45, and I can even go ahead and label them here too. 45, 45, and 45 and 45, right? So this might be something that helps us. You don't need to label all of them as 45, but sometimes when you know what shape you have, it helps to just label whatever you can, and then you might see what you have to do. So what I see right now is we have that angle CNE right here, so I'll write this out. So angle CNE, I know that it's 45 degrees just from labeling my properties of a square, but they also tell me that it's represented by 3A plus 2B. So I'm going to make that equation. Now I already know my value of A, so we can go ahead and actually substitute that in. Let's rewrite this equation. 45 equals 3 times 5 plus 2B. Now if we continue with our algebra, we'll get 15 plus 2B. And if we subtract 15 on both sides, we get 30 equals 2B, and we'll find that 15 is equal to our B value. Now this question wants the value of A plus B. So whenever you're writing your answers, I would write out A plus B equals, and then that's going to be 5 plus 15, which is 20. And I would go ahead and box my answer in there. So again, these questions may be multi-step, but whatever shape you have, try to label whatever you can from that, and it might help you see what you need to do. Now this is the second type of question here, where you might have to find the lengths of diagonals or the lengths of sides given different information. Now whenever you're dealing with sides or a diagonal, what you guys need to realize is that if we have a square, right, it tells us we have a square, I know all 4 of these angles are 90 degrees. So what you should be thinking about right now is when you have these 90-degree angles, we're creating a bunch of right triangles here. Now whenever you have right triangles, you might, it's in the mix. We might have to use Pythagorean theorem to help us solve for pieces here. Okay, now let's label what we have. So it says the diagonal is 3 radical 2. And it wants us to find the perimeter. So to find perimeter, we need all sides. And the good thing about squares is that all sides are congruent, so you only really need to find one side. So what I like to do is I'll label all of my sides just as a variable. So I know all of them are congruent. I can call it Y, I can call it Z, but I'm going to go ahead and label all 4 of those sides as congruent. And I'm going to try to find one of the sides first. It doesn't matter which one we decide to find, but what I see is a right triangle right here. Now in this right triangle, if I redraw it, we have x, and then we have our hypotenuse value of 3 radical 2. So we're going to use Pythagorean theorem here. Because we only have one variable, right? Like we're missing 2 sides out of the right triangle, but it's the same variable, so we're going to still be able to solve for it. So technically my A, we have x squared plus x squared equals 3 times the square root of 2, and all of that is squared. Now when we combine these, we're going to get 2 times x squared equals, now when you're doing this, when you're doing 3 times radical 2 squared, what you need to do is square each term. We'll do that over to the side here. So technically we need to do 3 squared, and then we need to take radical 2, and we need to square that as well. So when we square 3, we're going to get 9, and then rad 2 times rad 2 is just going to be 2. And then if we simplify that, we get 18. So that would be here, right? And if you wanted to put it in your calculator, you can do that as well. You can do 3 times, hit second x squared to get the square root sign. Make sure everything's in parentheses, and then you square the entire thing, and if you hit enter, you will get your value. Just be careful with your parentheses here. Now what we're going to do is divide by 2 to isolate our x squared. So we get x squared equals 9, and if we take the square root, we're going to get 3. Now always go back to your question, think about what our x value actually represents. Well, it's the value of all 4 sides of our square, so let's label those. So 3, 3, 3, and 3, and let's go back to the question. What does the question want? It wants the perimeter. So perimeter is adding up all 4 sides, so perimeter is going to be 3 plus 3 plus 3 plus 3, which is going to be 12, and we'll go ahead and box that answer as well. Now, there might be times where we're going the other way. Maybe it gives us a side length, and it wants us to find the length of the diagonal. It would be the same idea. You got to use Pythagorean theorem, but before we do that, I just wanted to go over quickly simplest radical form. So you can do this one of 2 ways, again, and this is a refresher. So you can either manually break up the radical by finding 2 numbers that multiply to this inside term. So square root of 9 times square root of 2. And then you want to see if any of them are a perfect square, right? If any of them can be broken down. So this radical 9 right here, I know that that's going to be equal to 3. But this square root of 2 I can't break down anymore. So that's going to just be 3 radical 2, and that would be radical 18 in simplest radical form. But the calculator trick, which I've taught you guys, but I'll show you again, what you can do is put the number that's inside, the term that's inside of the square root, do that, which in this case is 18, divided by, and in your denominator, you're going to put x squared. After that, what you're going to do is hit second graph, and then you're going to start at 0. You should see 0 error. And how you read this is the left side are the numbers that go outside of the square root, and the right side goes inside. So what you're looking for is the number or the row with the highest number, whole number on the right side. So right now I see 1 in 18. I see a whole number on the right, but that's just going to simplify to 1 radical 18, which isn't simplest radical form. That doesn't help us at all. So if we go back to our calculator and we start scrolling down, I see another whole number here. So another potential is 3 times square root of 2. Now you want to scroll down, and on the right, if you don't see any whole numbers in the near future, like you usually see this decimal getting smaller and smaller, you know you're done, right? So you want the row with the highest whole number in the right, which is 3 radical 2. Now let's use the calculator for a bigger number. So let's do 1344. So in our y equals, we would do 1344 divided by, x squared. Then we hit second graph. And again, the reason why the calculator trick is so great is because when you have big numbers like this, it's going to be really hard to manually do it. So we start at 0. We get 1 with radical 1344, which is not, that doesn't help us at all. And I'm just going to write down all my potentials here. So we have 2 square root of 336, and now I'm going to scroll down and see if we get another whole number, which we do. We get 4, we're at 84. Now I'm going to scroll down again and see if we get another whole number, and we do. We get 8, we're at 21. Now let's scroll down, and as I'm going, I'm not getting any more whole numbers. That decimal is just going to keep getting smaller and smaller and smaller. So my simplest radical form is 8 times the square root of 21. So make sure you guys are comfortable with that. Some questions might require you to get your answers in simplest radical form.